Good morning. Today I will be discussing the Rolle's theorem and the mean value theorem, or that is called Lagrange's mean value theorem. The Rolle's theorem and Lagrange's mean value theorems is defined for a given function f, y is equal to f of x. What the Rolle's theorem states that if a function y is equal to f of x is continuous and differentiable in the given interval, then at a point we can draw the tangent and the slope of the tangent will be parallel to the x-axis. That means the slope of the tangent will be 0. That means the tangent drawn to the given function y is equal to f of x will be parallel to x-axis. That is the statement of the Rolle's theorem. In the examination or in the question, simply will be asked, the function will be given to you, y is equal to f of x, or f of x is equal to sin x minus cos 2x, f of x is equal to 3x square minus 4x plus 1 in the given interval, and you will be asked to check whether the given function is defining under the given statement of the Rolle's theorem or not. That means, does it verify the Rolle's theorem or not? So before I go for the questions, first I will discuss what the Rolle's theorem states. Right? Let f be a function from a, b to r. Right? The domain of the function is a, b, and the range of the function is r. Be a continuous function. Be a continuous function. Continuous function in the closed interval AB and differentiable in the open interval AB. These two things very important, that the given function should be continuous and this should be differentiable such that f of a is equal to f of b. F of a is equal to f of b, where a is the lower limit, b is the upper limit in the given interval AB, such that f of a is equal to f of b. Then there exists c belongs to AB. There exists a number c in AB such that f dash of c equal to 0. Such that f dash of c equal to 0. Then we say that yes, the Rolle's theorem is verified. Now see the different part of this Rolle's theorem. The first is the given function y is equal to f of x is continuous in the closed interval AB. It should be differentiable in the open interval AB. And third point, f of a is equal to f of b. And the fourth point, f dash of c equal to 0, where c belongs to a comma b. That means from this it is very clear, whenever you are asked to verify whether the given function satisfy the Rolle's theorem or not, you have to check at the 4 points. The first point, you have to check whether the given function is continuous or not, differentiable or not. If it is continuous and differentiable, the third point, you have to check the value of f of a and f of b is also equal. After that, you have to differentiate y is equal to f of x and you have to ask to find the value of f dash of x. And after that, x will be replaced by c. That means f dash of c equal to 0. Now put f dash of c equal to 0 and the value of c must lie between A and B. Then we say that yes, the Rolle's theorem is verified. If I talk about the geometrical interpretation of the Rolle's theorem, what do you say that? See now, E given y is equal to f of x is a given function. The curve goes like this, suppose, right? Now, if we have, suppose if I take that interval a and interval b, in between a and b, now there is a point over c over here, and now if I draw a tangent at this point, now this tangent, this line should be parallel to the x-axis, right? Here this is a, f of a, this is b, this is f of b, right? And there is a point c here, up to this here it is c, this is f of c, right? That means at the point c, if you draw the tangent, that tangent will be parallel to x-axis, and that is the Rolle's theorem between any two interval a and b. Or if I draw the another figure, see that therefore you have to take care these 4 points. If I draw another figure for this x-axis, right? Now there is a function, right? And draw the tangent at this point, and interval I have taken, suppose I have taken the interval a and interval b, right? And now at this point c, if I draw the tangent, now this tangent line L is parallel to x-axis, right? That means that then we say that yes, that point C must lie between A and B. That means now 4 points. That means now in order to verify the Rolle's theorem, you have to take care of these 4 points. That means the first point, yes, the given function is continuous, the given function is differentiable. Find out the value of f of a and f of b. Check whether the f of a and f of b both are equal or not. When they are equal, then you differentiate the function y is equal to f of x and find out f dash of x. Now replace x by c so that f dash of c equal to 0. Now generally we will get the linear equation or quadratic equation sometimes, and find the value of c. Solve it for c because f dash of c equal to 0. Now the value of c must lie between the interval a and b, and then we say that yes, the Rolle's theorem is verified, right? Now I write the working rule for verifying Rolle's theorem. Working rule for verifying the Rolle's theorem. First point, right? Yes, the given function y is equal to f of x is continuous in the closed interval AB. Second point, y is equal to f of x is differentiable in the open interval AB. Third point, find and check for f of a is equal to f of b. Find the value of f of a, f of b, and check whether both of them are equal or not. And then the fourth, f dash of c equal to 0. f dash of c equal to 0. Fifth, check whether the c belongs to the interval AB or not. Then finally, yes, it is verified, or the Rolle theorem is verified. And hence, if all these 5 points, hence the Rolle theorem is verified. And if all these 5 points is satisfied, then you say that yes, the Rolle theorem is verified. Right? Now I'll go for one question. Right? Suppose the question is, verify the Rolle's theorem for the given function y is equal to x square plus 2 in the interval minus 2 to 2. Right? The question is, verify Rolle's theorem for y is equal to x square plus 2 in the interval minus 2 to 2. Minus 2 to 2. Right? Now, see the solution. Now tell me, y is equal to, here the given function we have, given function is y is equal to x square plus 2. Which type of function it is? Y is equal to x square plus 2 is a polynomial function, right? And we know that the given any polynomial function is continuous and differentiable, right? And therefore I will write yes, number 1, the given function y is equal to x square plus 2 is continuous in the interval minus 2 to 2. Second point, and when it is continuous, it will be differentiable also, and therefore y is equal to x square plus 2 is differentiable in the open interval minus 2 to 2. 2 points done. Now the third, f of minus 2 is equal to minus 2 whole square plus 2 is equal to 4 plus 2 is equal to 6. F of 2 is also 2 whole square plus 2, 4 plus 2 is equal to 6. That means f of minus 2 is equal to f of 2. F of a is equal to f of b. This is also verified. Now the fourth I will find out f dash of x. F dash of x will be how much? 2x. F dash of x is equal to 2x. Now we will put f dash of c equal to 0. It means what? F dash of c, that means 2c equal to 0. It implies that c is equal to 0 by 2 is equal to what? 0. Now the fifth point I will check whether the 0, c is equal to 0 will lie between minus 2 or 2 or not? Minus 2 and 2. Yes, of course, 0 lies between minus 2 to 2, and therefore we say that hence Rolle's theorem is verified. Got it? That means for any given function, whenever you are asked to check whether the Rolle's theorem is verified or not, there are 95% questions you will find that these two part is obviously it will be there. Yes, the given function will be continuous and differentiable. You know that the polynomial functions, the all trigonometric functions are continuous and differentiable in their own domain. That's why simply we will write for that yes, the given function is continuous and differentiable in the interval. Third, we will find out the value of f of a and f of b. Here we have calculated the value of f of minus 2 and f of 2. and after that we will find out f dash of c equal to 0, and after getting the value of c we have to check whether it lie in the given interval or not. Yes, here 0 lie between -2 and 2, and hence the Rolle theorem is verified. I think now it is clear. And now I'll discuss the mean value theorem. It is also known as Lagrange's mean value theorem. Second is now mean value theorem. It is also known as LMV, Lagrange mean value theorem. Right? Lagrange is the name of mathematician, and it is also known as Lagrange's mean value theorem. Okay. Now, let it is said let f is a function from AB to R, where AB is the domain of the function and the range of the function is R. Be a continuous and differentiable. Be a continuous and differentiable function. F from A, B to R be a continuous and differentiable function in the given interval, right? Closed interval A to B, it should be in differentiable, and in the differentiable in the open interval A and B. Then these two things are common. Then there exists C in AB, in between A and B, such that f dash of C is equal to f of B minus f of A upon B minus A. Here it is not f dash of C equal to 0. Now here what we have, f dash of C is equal to f of B minus f of A and upon B minus A. And of course here we will not have f of A is equal to f of B. Here f of A and f of B both will be different. This is the statement for the mean value theorem. That means a given function f be continuous and differentiable. Of course continuous in the closed interval AB, differentiable in the open interval AB, and f of A should not be equal to f of B. Then a number C which is lying between A and B such that f dash of C is equal to f of B minus f of A is equal to B minus A. And then we say that yes, the mean value theorem is verified as C belongs to A and B. Right? Then we say that yes, it is verified. You have to check. If C belongs to A comma B, then we say that yes, the mean value theorem is verified. That means again, for working rule for LMV or mean value theorem, again we have the 5 steps. Then the first step, we have to check whether the given function is continuous in the closed interval. In the second step, you have to check the given function is differentiable in the open interval. In the third step, you have to not to find out f of A and f of B. We will ask to find out f of B and f of B and put the value of f of B in this equation. F dash of C equal to f of B minus f of A upon B minus A. Right? And now after solving this equation, f dash of c is equal to f of b minus f of a upon b minus a, we will find the value of c such that the c will lie between the given interval a and b, and then we say that yes, if all the 4 points are satisfied, and then we say that yes, the mean value theorem is verified the given function. Right? Now see the geometrical meaning by the mean value theorem. For the mean value theorem, if you draw, this is your x-axis, this is your y-axis, right? Now in the given interval AB, you are asked to draw the graph of that. Let us see now. Let us see that one goes like this: f of a, f of b, right? Here this is a, this is f of a. Here this is b, this is f of b. Now between a and b, there is any point where we can draw the tangent. Suppose if I draw the tangent here, draw the tangent here. Now this line, yes, now this point C, right? This is now C and f of C, C and f of C. Now what is it? This line L and this line, the coordinate of this point is A, f of A. The coordinate of this point is B and f of B, right? The coordinate of this point is C and f of C. At this point we have drawn the tangent, that is line L, and here we have joined the line A and B. Now if I ask you, so what is the slope of this line which is passing through these 2 points A and B? This point suppose A, this point is B. What will be that? F of B minus f of A upon B minus A. Don't get confused. Yes, this is now f of B, this is f of A, this will be what? F of B minus f of A. This difference is what? B minus A. Tan theta, that is known as the slope of the any curve or any line. So now tan theta is equal to perpendicular upon base. That means what? That will be f of B minus f of A upon B minus A. F of B minus f of A upon B minus A. And this is what? This is the slope of the line AB. And we have discussed that this is equal to what? F of B minus f of A is equal to B minus A is equal to what have written here? F dash of C. It means what? It means what? In the mean value theorem, in between A and B, if the given function is continuous and differentiable, and if you draw the tangent at the point C, then this line L, that is the tangent L, will be parallel to not the x-axis. In the Rolle's theorem we have discussed about the x-axis. Here not x-axis, this is now that line which is tangent will be parallel to the point joining A and B. That is, that will be parallel to the line AB. This is the difference between the Rolle's theorem and LMB. And therefore, now I think it is clear. Yes, in this Lagrange's mean value theorem, or simply mean value theorem, if you draw the tangent at that point C, that line, the tangent line, will be parallel to the line passing through the point A and B, whose coordinates are A and FA, B and FB. Right? Now I will go for one questions for this mean value theorem. The question is, Verify the mean value theorem for f of x is equal to, question is verify mean value theorem for f of x is equal to x square minus 4x minus 3, x square minus 4x minus 3 in the interval AB, where a is equal to 1 and b is equal to 4. In AB, where a is equal to 1 and b is equal to 4, right? Okay, now see the solution. Which type of function it is? Here f of x is equal to x square minus 4x minus 3, and therefore the given function is a, which kind of function it is? Polynomial function. And we know that a polynomial function is continuous and differentiable. That will write yes, f of x is continuous in the interval 1 and 4. Second, f of x is differentiable in the interval 1 and 4. This 2 point. Third, we will not find f of a, f of b, we will find out the value of f of a and f of b. F of x is equal to x square minus 4x minus 3, and therefore f of 1, a is equal to 1, f of 1 is equal to 1 minus 4 into 1 minus 3, so 1 minus 4 minus 3, 1 minus 7 minus 6, right? And f of 4 will be 16 minus 16, 4 4 is 16, 4 4 16 minus 3, and that is equal to minus 3. And therefore, now fourth point, f dash of x will be equal to 2x minus 4. Differentiation of this, x square minus 4x, 2x minus 4, and therefore f dash of c equal to 2c minus 4. Now what I will do? Fifth point, f dash of c is equal to f of b minus f of a upon b minus a. It implies that what? F dash of c is 2c minus 4 is equal to f of b. F of b is f minus 3 minus 6 upon b minus a, 4 minus 1. See, f of b is what? F of 4, because the value of b is given 4. F of b is minus 3 minus f of a. F of a is how much? F of 1, that is minus 6. So now 3 plus 6, 3 minus 3 plus 6 upon 3, and that will give you 3 by 3, that is 1. So now 2c minus 4 is equal to 1. It implies that 2c minus 4 is equal to 1. It implies that 2c is equal to 5. It implies that c is equal to 5 by 2, 2.5. Now see, 2c minus 4 is equal to 1, 2c is equal to 5, c is equal to 2.5, and 2.5 belongs to 1 and 4. Yes or no? Yes. 2.5 lie between 1 and 4, and hence LMV is verified. Done. This is the simple way to do the questions for the verification of Rolle's theorem and Lagrange's mean value theorem. Right? Now I will go another question for this. Right? Right? In the exercise, if you will see in the in your NCERT book, the number of questions are very less. That's why I'll do 1 or 2 questions which is not there in your book, and after that this part will be complete. Let the question is, verify mean value theorem. Verify mean value theorem for f of x is equal to sin 2x plus 2 sin x. 2 sin x plus sin 2x in the interval 2 sin x plus sin 2x in the interval 0 to pi. Right. Now see the solution of this part. F of x is equal to what? 2 sin x plus sin 2x. Sin x and sin 2x, both of them are the trigonometric functions, and you know that any trigonometric functions, that especially the sine function, is continuous and differentiable everywhere. Sin x and sin 2x is continuous and differentiable everywhere, right? Therefore, the first 2 lines will write simply, yes, the given function is continuous and differentiable in the given interval. Or we can add line, yes, we know that sin x is continuous and differentiable everywhere, and the composition of 2 functions is also continuous and differentiable everywhere, because see, there are 2 functions, no? Sin x and sin 2x. If I take it this as g of x, this if I take as h of x, then this is what? G of x plus h of x. And we know that when the 2 functions are continuous, their addition is also continuous, right? That is, their sum and their difference is also continuous. Not only sum and difference, their division and their multiplication of that 2 functions will be also continuous and differentiable. And this I have discussed when I was discussing the part continuity, right? And I have made the points for that also, and I think you must have written in your notebook. Once you can go through it. That means for time being I can write, yes, here sin x and sin 2x is then trigonometric functions and it is continuous everywhere, and therefore as we know that the sum and the difference, the sum of any 2 trigonometric functions is also differentiable and continuous, and therefore it will be continuous and differentiable everywhere. By the way, I will not do all these things, simply I will write now the first point here. Given f of x is equal to 2 sin x plus sin 2x, and therefore the number 1, given function is continuous in the interval 0 to pi, right? And given function is differentiable in the open interval 0 to pi. These 2 lines will write that, or simply in place of given function we can write f of x. Given function, in place of this we can write f of x is continuous, f of x is differentiable in this interval, right? Now we'll find out f of a and f of b. Here f of a is what? F of 0. Now f of 0 is equal to 2 sin 0 degree plus Sine 0 degree. How much? 0. Right? F of pi 2 sine pi plus sine 2 pi. This will be also how much? 0. Any problem? F of 0 is 0, f of pi is also 0. That means f of a is equal to f of b. This part is also verified. Now we'll find out f dash of x. Right? Now f dash of x is equal to 2 cos x plus the 2 differential of sign is cos x, sin 2x, cos 2x into 2. Yes or no? 2 cos x plus 2 cos 2x. Isn't it? And therefore, now we will find out that f dash of c equal to 0. It implies that 2 cos c plus 2 cos 2c equal to 0. It implies that 2 cos c is equal to minus 2 cos 2c. 2 and 2 is cancelled. It implies that cos c is equal to minus cos 2c. Isn't it? Cos c is equal to minus cos 2c equal to 0. Or I can write now cos c cos 2c plus cos c equal to 0. And I have to find the value of c. Now what to do? Come on. Cos 2c plus cos c equal to 0. And I have to find the value of c. What we can do now? See, cos 2c can we write in terms of cos c? 2 cos square c minus 1. This can I write now. 2 cos square c plus cos c minus 1 equal to 0. Can I write? Yes. Cos 2 is 2c. 2 cos square c minus 1. Simple formula. Plus cos c. So now 2 cos square c plus cos c minus 1 equal to 0. Now it is a quadratic equation in terms of cos c. So now find the value of cos c. 2 cos square c plus cos c minus 1 equal to 0. It is a simple quadratic equation. Now we have 2 cos square c plus cos c minus 1 equal to 0. If we go for finding the value of cos c, now you have to find out. Right? Can I write now 2 cos square c plus 2 cos c minus cos c minus 1 equal to 0. Right? So now 2 cos c common, cos c plus 1 minus 1 common, cos c plus 1 equal to 0. So now we have cos c plus 1 and 2 cos c minus 1 equal to 0. It implies that cos c is equal to minus 1 and cos c is equal to 1 by 2 value we have. Cos c is equal to minus 1 and cos c is equal to half. Now tell me, when I say cos c is equal to half, it means c is equal to what? Pi by 3 can I write? And when cos c is equal to minus 1, it implies that c is equal to pi cos 180. Cos 180 degree minus 1. Cos 60 degree 1 by 2. The value of c is pi and pi by 3. And now tell me, pi and pi by 3, and we have the interval given 0 to pi. If you remember, the interval which I have written that was 0 to pi. That's why now this pi, I cannot take here the value for cos is equal to half, and now c is equal to pi by 3, which belongs to the interval 0 to pi, lying in between, not pi, because pi lie in the closed interval, not in the open interval. That's why I cannot take this value of pi. Here now pi by 3 belongs to 0 to pi, right? And hence the LMV is verified, and hence LMV is verified, and that is done. This is the simple way to do the questions. And now I hope that you can do the problems of the whole exercise. There is simply one exercise there, and hardly there are 4 or 5 questions which you can do. That's all about the Rolle's theorem and Lagrange's mean value theorem. Thank you very much. Take care of yourself and do well.